Here's a question, a pretty easy one that I'd like you to think about as we go through the contents of this video. Why are estimators called a high-level way to perform tasks like linear or logistic regression in TensorFlow? Estimators are a sort of convenience. They are cookie cutter mathematical models which are made available to us by TensorFlow. These are APIs for standard problems such as linear regression, linear classification, and so on. These are high level APIs which allow us to outsource all of the complexity of the gradient descent into the estimator. Estimators really come into their own when we are working with very complicated neural networks with large feature vectors. Those feature vectors might contain hundreds of attributes. Estimators are a quick and easy way to infer relationships between different attributes inside the feature vector. Estimators can also be extended by plugging custom models into a base class. From a software engineering perspective, this is an interesting extension because it relies on composition rather than inheritance. If you're familiar with the strategy design pattern, that really is how estimators can be extended. We've now cycled through implementations of both linear and logistic regression in TensorFlow, and so we are quite familiar with all of the wiring up that goes into setting up these models. We need to set up the computation graph, specify the cost function, instantiate a gradient descent optimizer, make decisions about the batch size and the number of epochs, and finally set up a for loop to iteratively invoke that optimizer. This is the basic outline that we need to adopt for both linear and logistic regression, and it's quite clear that this is a lot of wiring for operations as common as these two. This is where estimators come in handy. These are a high level way of performing these same algorithms with just a few lines of code. So here's the basic idea of how all estimators work. We need to instantiate an estimator object. We also need to specify a list of all possible features out there. This is a very large, possibly very complex feature vector. We then need to create an input function which will tell our estimator object how and what data from that feature vector it cares about. This input function will also specify the number of epochs and the batch size. And that basically is all that we need to do. The estimator object will take on the responsibility of instantiating the optimizer, fetching data from the feature vector, carrying out whatever numerical optimization is required to minimize the cost function, and give us back a nicely trained model which we can then use to evaluate new test data. This is particularly useful if we are dealing with a very complex neural network. Notice that in a neural network, all of the data that flows between any layers of that neural network are in a sense elements of a large feature vector. One of the drawbacks of neural network based solutions is that we don't have a whole lot of visibility into the relationships between those feature vectors, particularly those which lie in hidden layers. Estimators help provide a solution. We can very quickly look for simple relationships such as those implied by linear or logistic regression between intermediate features inside our neural network, and we can do so without having to know anything at all about the computation graph, the cost function, or the optimizer. All that we need to do is to make decisions about the number of epochs and the batch size, and the rest is handled for us by the estimator. Hopefully, we now can answer the question that we posed at the start of this video. Estimators are a high level way to perform linear or logistic regression or similar operations in TensorFlow because they abstract away many of the nitty gritty details of doing so yourself. You don't have to choose which gradient descent optimizer to use. You do not have to make decisions about whether to use mini batch or stochastic gradient descent. All of these decisions are handled for you. That's why estimators are a high level API.